of final thoughts about the Earth and the Moon system. Students often have questions about the Moon because they don't really understand it. I know for myself, when I was a boy, I looked at the Moon and the crescent made sense to me because in my interpretation, the crescent moon was simply the shadow of the Earth, taking a bite out of the surface face of the Moon. Well, I was wrong. It was not that at all. You see, I could never understand why a gibbous phase existed. It didn't make sense to me that a Earth could cast a shadow with the sort of opposite affected shadow. I didn't get it, why there were phases, but nobody ever explained it to me. I remember the Moon being a place that some men went to in a mission called Apollo. I recall vaguely the era when Neil Armstrong and Buzz Aldrin set foot on the Moon. And I'll always look upon the Moon race as a spectacular era of time, of achievement and discovery. To imagine flying through space for 3 days to land on a body that's in motion itself, really remarkable thing. But we know so much about the Moon now, and the best thing a student can do, best thing a teacher can do, is go outside and look at the Moon. I always recommend that somewhere in most people's homes, there's an old pair of binoculars covered in dust, sitting on the top shelf of the closet perhaps, maybe down in the crawl space. Pull those old binoculars out, blow the dust off of them, and go outside and look at the Moon. Notice the shadows that you see. Notice the craters. Notice the difference in the colors of the surface of the Moon, some lighter and darker colors. Take note of the shape. The Moon is a ball, and it's very obvious when you look at it with a pair of binoculars. Go out night after night and notice the position of the Moon relative to other objects around your house, in your neighborhood. Maybe one night the Moon at 7 o'clock is above that tree, but the next night the Moon is not above that tree anymore at 7 o'clock. Now it's above your neighbor's house. It seems to have moved. And it has. It's moved about 12 degrees through its orbit. Notice these things. Watch them draw the Moon. Draw the phases as you see them each night. Notice the times that they set and the times that they rise. Just continue to be curious about the way the Moon moves around and notice the geometry. Say to yourself, well, I can see that the sun has set over here. And I'm on Earth here, and there's the Moon there. That's an angle. I could estimate that angle, and I could use that estimation to make sense of the position of the Moon in its orbit around the Earth, and then understand why the phase appears as it does. Now you have to understand, of course, that the Moon, the planets, they've all been described mathematically. There's been great experiments done over the course of history. Ancient astronomers did these same things. There's so much that could be explored with your students in terms of angles and velocity. If I knew the circumference based on the formula of 2 pi r, I could divide that by the time it takes to get around the Earth, and then I have a velocity. And this is an interesting thing to understand how fast these objects are actually moving. There's so many things, and I'll post some of these things in the notes below this video. I'd also like to refer you to my podcast, Science 360. I've done a podcast episode, and that will go through a few more details as well, things that you could learn and take to your class and teach your students. So certainly if you have questions about the Moon that I haven't covered here, please place them in the comments, and I'll do my best to either answer them directly, or what I'll do is even make subsequent videos to answer some of the questions that may have come up. So until all that happens, I encourage you to go and teach about the Moon. It's one of the most obvious things in the night sky. And people wonder, and people have questions, people love to talk about it. So have fun teaching about the moon.